Hey Pre-Calc, back with part 2 of the 2.1 section videos. Alright, so they give you 2 points, and they ask you guys to determine what the distance between the 2 points and the midpoint are. Now in previous math classes you guys have used the formulas. I want to make sure you're rock solid on how those formulas came about. So when you think about these two, I can maybe plot them first of all. So here's negative 7, 0 for A, and here's negative 2, negative 4 for my B coordinate. And what they want to do is they want to know what's this distance right here, and what's the exact middle point of those two, of that line segment. So when you think about distance, I can throw the formula at you, but I first wanted to just talk about how we're really talking about a right triangle here in which that distance you're talking about is the hypotenuse of that right triangle. And if you remember the Pythagorean theorem, it stated that a squared plus b squared is equal to c squared. So when you think of the distance formula itself, it's basically like saying, what's the difference between your two x coordinates? So if you think of this as x1, x2, it's sort of like saying, hey, what's the difference between these two? Because this would be negative 7 minus negative 2. That gives you that whole distance there. And then you square it. Okay? And then the distance between the y values is y2 minus y1. Or y1 minus y2, rather. Since you're squaring it, it doesn't matter which one you put first. A squared plus b squared equals your c squared. That's the Pythagorean theorem, and what the distance formula does is it just says, hey, instead of using c, let's use d for distance, and let's square root both sides so that d is by itself. All right, we've got our distance formula. D equals root x1 minus x2 squared plus y1 minus y2 squared. So we don't have to do any visual graphing now if we want to just find the distance between 2 points. We can just say D equals roots. Now take the x's, negative 7 and negative 2, square it, plus 0 minus negative 4. You're going to square that. Negative 5 squared is going to be negative 5 times negative 5, which yields a positive value. And then 0 minus negative 4 is like 0 plus 4. 4 squared is 16, and you're left with root 41. 41 is a prime number, so we can't simplify that any further, so root 41 is our distance. All right, the midpoint formula, we're basically saying, if we go back to our original, here's negative 7, 0, here's negative 2, negative 4, it's kind of like saying the exact middle of this line segment is going to be the exact middle of our x's. So our x's are negative 7 and negative 2. It's the exact middle ground between those two. So what we do is we find the average of the x's. So we add them together and cut it in half. That's how you get the average of the x coordinates. For the y values, this is exactly halfway between 0 and negative 4. So you take the y values and you cut those in half. That's how you find the average of the y values. So this is the midpoint formula. I think it's a lot simpler to come up with than the distance. It makes sense. So then negative 7 plus negative 2 is negative 9. Zero plus negative 4 is negative 4. and you just cut those in half. So you get negative 4.5, or negative 4.5, or really negative 9/2 works too, and negative 2. So there's the midpoint, which it makes sense. It's about negative 1, 2, 3, 4.5 from my graph, and exactly negative 2. Number 15. Number 15 gives us a graph already. It plots the points A, B, and C. Looks like A is 6, 3. B is 1, negative 2. And the C coordinate is negative 3, 2. Show that the triangle with vertices ABC is a right triangle and find its area. So how do we determine if this is a right triangle? Well, first I got to convince myself visually that I think it's a right triangle. So if I connect the dots, if it is indeed a right triangle, it seems like our right angle would occur at the vertex B. By the way, the vertex just basically means a point on the triangle where two line segments meet. So if you'll recall from previous math classes, line segments that meet at right angles are said to be perpendicular. And what that means is, besides meeting at right angles, that means their slopes, the slopes of their lines, so now we're going to be digging a little bit into linear things, that their slopes are negative reciprocals. So a negative reciprocal basically means if you're given a number that represents a slope, so say as an example, negative 2/3 is the slope of one of your line segments. Positive 3/2 would create a reciprocal that's opposite signed. So these would be negative reciprocals, negative 2/3 and positive 3/2. So we just have to confirm that the slope of CB is a negative reciprocal with the slope of AB. So let's do that. So BC, its slope is going to be the same as its rise over run. So the vertical rise to get from B to C, or vice versa, I'm just going to start here, means you go down 1, 2, 3, 4 units. So down 4 would be the rise. The run would be right 1, 2, 3, 4. Okay? And that ultimately equals negative 1. AB, its slope, its rise over run equals down 1, 2, 3, 4, 5 over 1, 2, 3, 4, 5. Now, notice I went left, so it's -5 over -5. Right and up are positives, down and left are negatives. So that equals +1. Now this is actually the toughest one to confirm their negative reciprocals because sometimes people just don't visualize it properly. But -1 is the same as -1 over 1. And if you flip that fraction and then make it the opposite sign of what it was originally, so it was originally a negative, now it's a positive. Those two are negative reciprocals. -1 and +1 are reciprocals. So this confirms the perpendicularity. This confirms it's a right triangle. So we'd maybe off to the side here say, definitely a right triangle. Now the question is, how do we determine the area of this triangle? Well, it'd be nice to say what the area of the triangle is first. The area of a triangle is half the base times its height. So in this context, we would look at either this as the height and that as the base, or vice versa. The hypotenuse in this case will not act as the base unless you dropped what's called an altitude from here down to there. And I don't think we want to do that because we've already got two line segments that we can work with as the height and the base. So I'm just going to say that, I don't know, I'm going to say this is my height and this is my base. So height, base. They could be switched around if you wanted to. So if we need to figure out what the length of h is, then you can use the distance formula of CB to figure that out, or the distance formula of AB to figure that out. So the distance between CB, h equals basically the distance or length. I'm just going to say the length of CB. Can you guys see that? So that'd be root -3 minus 1 squared plus 2 minus -2 squared. So that's -4 squared is 16. 4 squared is 16 again. That's root 32. Now, the root 32 can be simplified. If you think about how 32 breaks itself down, it's 2 times 16. That's a perfect square. All right? So it's like root 2 times root 16 is root 32. Root 16 is 4, so it's 4 root 2. Yeah. If you want to avoid the distance formula entirely, you can actually do this. You can say, hey, let's call this length my b value, and then create a right triangle like this. You're allowed to do that if you want to. And I could say it's a distance of 5 here and 5 there. B squared, sorry about that extra stuff. B squared plus 5 squared plus B squared equals 5 squared plus 5 squared. So that's another way to talk about it. B squared plus, I'm sorry, I'm struggling to speak right now. Give me a moment. Okay, the Pythagorean theorem applied to that triangle will give us b. Okay, let's see if I can do this. B squared equals 5 squared plus 5 squared, which is 25 plus 25, which is root 50. And root 50 also is a product of a perfect square. It's 2 times 25. So root 2 times root 25, 5 root 2 is my base. So I've got my base, I've got my height, times a half. One half base times height equals 1/2. My base is 5 root 2. My height is 4 root 2. How would I do this? I would multiply the inside roots together. So root 4 times root 2 is root 4. 4 times 5 is 20. Times a half is 10. Root 4 is actually 2. So it's 20. 20 square units of whatever we're talking about. So, my apologies, my explanations for some very simple things took a lot longer than I intended, but I think I really showed exactly what you need to know about how the distance formula works, how it's related to the Pythagorean theorem, and how the midpoint formula kind of fleshes itself out. All right, slowly but surely we're rolling through this. Next video, I'm going to conclude section 2.1.